Hello there, today we'll be doing maximum depth of binary tree. So in this particular problem, what we're trying to do is find the maximum depth of a binary tree. Here in this binary tree, the maximum depth is going to be 3. So here's how we count that. So the first layer is going to be 1, the next layer is going to be 2, and the third layer is 3. So each layer is increased by 1. So we start with 1 here, 2, and 3. We can count this using a DFS, or we could also count using a breadth first search, BFS. So to use a BFS, we could do a queue and have everything inside a queue and go layer by layer until there's nothing left. In this case, we will be doing every single node to get the maximum depth, which is at the end. Or we could just do a DFS call, use a pre-order search, or it doesn't actually. There is no order. There is no operation. So it's traversal of our tree. So let's check this out. So let's do a DFS of a roots and a depth. So we need a maximum depth equals 0, and we need a non-local. So now if not roots, what we're gonna do is set the maximum to equal to the max of the maximum and the depth. I think we should change this name to maximum depth for clarity. Maximum, no one knows what that's about. And now we can return. So as I said, there's no operation to be done here. What we're gonna do is call DFS on root.left and depth plus 1. Otherwise, DFS root right depth plus 1. And what we're gonna do now is run DFS. So DFS of roots at depth of, let's say, 0. We could also just put maximum depth in there, but hopefully it doesn't make things too wonky. Actually, we can do that, can't we? Sorry about that. I was not in frame. Let me just move my... So we're gonna edit this a little bit after we're done, and we're gonna send in the maximum depth. Run. And submit. So, oh, that's some bad timing, but let's try this instead. Let's throw this in here, and that way, yeah, that doesn't do anything. That's just confusing. I truly believe that's just confusing. Alright, let's just throw the 0 in here. Alright, so with that, we are done with this particular problem. We could do this in terms of a stack. When we're using a stack, that is what it means is that we're going to be popping from the first in, last out, and that means that we'll keep appending items and yeah, and popping them at each layer and going all the way to the bottom. So let's create a stack. I think what we want to do here, instead of doing this iteratively, is to do this with the DFS call. I mean, given the nature of this problem, but we could do this with while stack. So what we're going to do is node and depth is equal to stack.pop, and the max depth is equal to the max of max depth again, and the depth, and if there is a node, then stack.append node.left and depth plus 1. And we repeat the same code. With that, once there are no more items in the stack, we can return the maximum depth. But to do this truly, like we should use a queue, and yeah, so we could call this a queue, and we could call this a DQ. And we could do a pop first or something, right? Let me go look at some documentation. I haven't used the DQ in a while. As you can see, I've even spelled DQ wrong. Let's see, it's a DQ. All right, so it's called a DQ, and what we need to do is actually wrap this like so. Another thing is we need to do an insert? No. Append, remove? No, that's not what we want. Rotate? No. Where are the functions? Pop left. Pop. So pop is the right end and pop left is the left end. Okay, cool. All right. So pop left, and we just need to append everything to the queue and just pop left. I don't think it matters if we do it layer by layer because it's a queue. I mean, because we don't really care. Whoops. So let's check that out. Of course, we should be doing this by layer. Wow, it's much faster this time. I think it's just the problem set that we're given. If we do this again, it might be slower, might be faster. So with that, we have learned to do this with a stack, a queue, and doing this in recursive manner, all of which are pretty cool. And I hope you enjoyed today's video. If you have any questions, please comment below. And if you enjoyed it, like and subscribe, and I'll see you again in the next one. Bye.